students, today we will discuss about microscopes and telescopes. In last video we discussed about magnifying glass or simple microscope. In this video we will discuss about compound microscope and telescopes. Now let's see the definition of compound microscope. What is compound microscope? Compound microscope, it is an optical instrument. What is it? It is an optical instrument used for observing highly magnified image. Now let's see its ray diagram. Before ray diagram, I clear that definition of optical instruments, magnifying glass or simple microscope and compound microscope are nearly same. I can say although same. Okay. Now let's see the ray diagram for this microscope. Remember, we had taken only one lens for the image formation of magnifying glass. Here we will consider two convex lenses and we will form the image. Let's see the image formation. Let's see. Here we will make a convex lens. Its principal focus, we will put an object here. It's an object. Let's name it A, B. Light ray goes parallel to the principal axis, then its incidents on the focus, and here this light. Such type of image formation here goes from the center and reflects back to the center. Here is the image formed. Here we consider another convex lens. Let these rays strike the convex lens. These rays strike the convex lens in such a way. Now, it's the optical center for this lens. We will name these two lenses. It is objective lens. That's why it is named after FO, and it's eye lens. Now we have to refract incident light on this lens also. We have to image formation at finite distance. We do not form image at infinite distance. Let's see. From this ray, a ray from the center strikes and refracts back to the center. Such a type. A ray from this point and another from this point also strike this surface. This point. Now, where is the final image formed? It is the final image known as, इसको हम नाम दे देते हैं, it is named as A dash, B dash, and this image is named as A double dash, B double dash. Okay. Now let's place here. Its name is A1. Let this ray strikes on the center, and I said you that an image forms an angle alpha with the optical center, alpha ni beta, and object alpha. Let's see. This angle is alpha and this angle, this is image, and this angle is beta. It's the ray that's make angle with the optical center. Final image forms an angle with the optical center and initial object forms the angle with optical center. It means जो हमने starting में object लिया था at the starting position, वो angle बनाएगा optical center के साथ alpha, और जो हमें final image मिलेगी after two refractions, वो angle बनाएगी optical center के साथ beta. Is it clear? Now place here I It's I. It is the position of I. Position of I. Okay. Now let's do derivation. The distance between these two lenses from here, D, and it is U, image distance. D is the least distance of distinct vision. I said earlier also it is the least distance of distinct vision. Now let's see magnifying power. Beta by alpha. In last video we have already discussed. M is equals to, angles are small, tan beta divided by tan alpha. Similar derivation. Not so much different. Now let's take triangle. In triangle, it's the point C1 and it's the point C2. A double dash, B double dash, C2. Tan beta is equals to A double dash, B double dash divided by C2B dash. Sorry, C2B double dash. C2B double dash. It is tan beta. Now let's take triangle. In triangle A1B double dash C2. A1B double dash C2. Tan alpha is equals to A1B double dash divided by C2B double dash. C2B double dash. Also A1B double dash. A1B double dash is equals to, A1B double dash is equals to AB. Tan alpha also can be written as AB divided by C2B double dash. Now let's divide M is equals to tan beta divided by tan alpha. M is equals to tan beta, A double dash, B double dash, C2B double dash into tan alpha divided by tan alpha. AB, C2B double dash cancelled out. M is equals to A double dash, B double dash divided by AB. Is it clear? Now let's multiply and divide this equation by A1B dash. A1B dash. A dash B dash. A double dash B double dash divided by A dash B dash into A dash B dash divided by AB. This A double dash divided by A dash B dash. A double dash, A double dash, A dash B dash. It is the magnification for islands. It acts as object for islands and its image. So we can write M of E, and similarly it is for objective lens magnification MO. Is it clear? And we have proved earlier in case of simple microscope this 1 plus D divided by FE. Remember? Have you remembered this thing? Then MO is equals to C1B dash divided by C1B. Let's see. M is equals to M of objective lens C1B dash. Where is C1? C1 and B dash. C1B dash divided by C1B. C1B. It's the magnification for, we can say that it is V and it is U. So we can write it as plus V naught divided by U naught. U naught, it is not UO. Objective length, focal length. Then equation second becomes, this is the equation second. M is equals to M into M naught. Then equation second becomes 1 plus dy divided by F into V naught divided by minus of U naught. We can also write magnitude of M is equals to 1 plus d divided by F into V naught divided by U naught. It is the magnification. As we remember, length formula is this. Multiplying by V naught both sides, we get this. Then equation third becomes, here V naught by U naught, we will put here 1 minus V naught by F naught. Then the equation becomes this. This is the final result. 1 minus V naught by F naught into 1 plus D by Fe. Is it clear? When the final image is formed at infinite, second case, then the magnification becomes minus of L divided by F naught into D divided by Fe. Is it clear? L is the length of microscopic tube. That is VO. VO becomes L in this case. Okay? When final image is formed at infinity, then it is known as normal adjustment. It is an important question when the microscope is in normal adjustment, when the final image is formed at infinity. I will also tell you how the final image is formed at infinity. Let's see how will the image formed at infinite. Same type of diagram till this. I am drawing rough diagram. Here this, where will the image formed? It's so as, yeah. Image is formed nearly here. Then it strikes here, it strikes here, and it strikes here. And backward direction, that's means here image is formed as infinite. It is image formation at infinite. It means it is the focus of eye lens. Okay. Now let's see last topic of today, astronomical telescope. It is an optical instrument which is used for observing distinct images of heavenly bodies. It is used for observing distinct images of heavenly bodies. In normal adjustment of telescope, image is formed at infinite. It is the normal adjustment of telescope. Here is the objective lens. In the microscope, that is compound microscope. In compound microscope, focus of objective lens, focal length of objective lens is lesser than the focal length of eye lens. That is, size of objective lens is lesser than eye lens. But in case of astronomical telescope, size of objective lens is greater than eye lens. Some parallel ray, not parallel, inclined at an angle, some angle, strikes on the objective lens, refracts, refract. Here the image will be formed. This ray goes here, goes here. Now we have to do same thing. This ray appears to converge, appears. Means the image is formed at infinite distance. Okay? And I said that initial object makes an angle alpha and final image, that is, it is an angle beta. Okay? Name it as A dash, B dash. Here is the focal length and Fe. Because when the ray parallel to the principal axis converges at focus, and so that it is the focus of the objective lens. But when the final image is formed at infinite, it should be placed on the focus of that lens. Means I will explain it in Hindi. यहाँ से पैरेलल रेज आई थी. अगर किसी लेंस के पैरेलल रेज आती हैं प्रिंसिपल एक्सिस के, तो कहाँ कन्वर्ट होती हैं? फोकल लेंथ पे, प्रिंसिपल फोकस पे. तो ये प्रिंसिपल फोकस पे कन्वर्ट हो गई. तो ये क्या हो गया? फोकस किसका? ऑब्जेक्टिव लेंस का. अगर हमें ये हो गया ऑब्जेक्टिव लेंस का फोकस. अब देखिए हमें फाइनल इमेज इनफाइनाइट डिस्टेंस पे कब मिलती है? जब हम उस लेंस के लिए वो ऑब्जेक्ट फोकस पे रखें. मीन्स हम इस लेंस के लिए ऑब्जेक्ट कहाँ रखें? फोकस पे. तभी तो हमें फाइनल इमेज इनफाइनाइट में मिलेगी. तो ये किसका फोकस हो जाएगा? आई लेंस का भी यही फोकस हो जाएगा. तो हम डेरिवेशन करें. देखिए m इज इक्वल्स टू बीटा बाई अल्फा, tan बीटा बाई tan अल्फा. सेम सा डेरिवेशन है, एक बार आप देख लीजिए. सिमिलर डेरिवेशन. Here for figure 2, I will explain it until here it is clear. Second figure, I mean, for second figure, image is not formed at infinite, it is formed at finite distance. Such type of image formation took place. Such type of image formation, it is B dash, A dash, it is A double dash, B double dash. Now it is C1, it is C2. Now let's see another derivation. Similar. Clear? That's all about astronomical telescope. Read it thoroughly. That's all about the ray optics and optical instruments. I hope you liked my video. अगर आपको वीडियो पसंद आए तो शेयर करें, कमेंट करें, कोई प्रॉब्लम हो तो आपको न्यूमेरिकल से रिलेटेड एनी अदर प्रॉब्लम, और चैनल को सब्सक्राइब करें. थैंक्स, बाय बाय.